In this video, we will make a clamper circuit on Multisim. This circuit changes the DC level of an input waveform without changing the appearance of it or the peak-to-peak value. This circuit uses a resistor, diode, and a capacitor. And this is also called a level shifter. So the two types of clamping are positive clamper and negative clamper. In this circuit, the value of load resistor and capacitor matters. The time constant tau, that is R multiplied by C, must be large enough so the capacitor does not discharge when the diode is not conducting. So let's see this in the circuit. First, we need an AC voltage source and a ground and resistor, uh, resistor of 10K. And a capacitor of 1 microfarad and a diode. The diode will be 1N4007. And now we have to connect these. And to see the waveforms, we can use an oscilloscope. So we can connect the input to A and the output across the load. And again, change the color of the segment. So now we should see that the diode, there should be clamping. So red is the input and blue is the output, but we can see that it's not completely clamped at 0. That is because of the 0.5 voltage drop across this. So we can add a reference DC voltage and the drop is 0.5. So, and since this is the drop here is plus 0.5, here also, here it should be negative. And now we can see that it's clamping at 0. So how the circuit works is in the negative half cycle, the diode will be forward biased. So all the current flows through this loop, and the capacitor gets charged to the value of the AC voltage here, peak value, and the voltage V naught output we get is 0, because this is a short circuit, and the current would flow through the short circuit and it would be 0. And in the positive half cycle, this is an open circuit, and the current that flows through this uh, will be a value of this, and also the charge stored in capacitor itself, so it will be 2 times of that. So that's why we see that it is the same value, but here 2 times, minus 2 uh, in this case. And this is a negative clamper. We can design the same for a positive clamper, which pushes the waveform in the positive end towards the positive side. In this, the values of capacitor and resistor are the same. In this, we have used a diode which has a drop of 0.7. So when we see the output of this, in this case, blue is the input and red is the output. So we can see that it has been properly pushed to the above this. And the peak to peak value remains the same, which is like 1 unit here. And even this is a unit. It's a unit. And that is a positive clamper.